Hey everyone, I hope you're doing well. Thanks for checking out this video. Before we get started, if you haven't already subscribed, please do subscribe to my channel. It helps me understand if you are really enjoying these videos that I create. Also, if you have any feedback for me, any ways I can improve, please do let me know in comments. It really helps. Um, okay, so the topic for this video is let's have a look at binary search and let's actually implement a binary search using Python 3. Python happens to be the language that I usually code in at my work, and I'm most familiar with Python as a programming language as compared to other programming languages. So I'm going to use Python for this particular video. Okay, so first of all, what is binary search? And I'll share a link to this presentation in the description of the video. So binary search. Okay, fundamental assumption with binary search is that the data that you pass to any binary search algorithm, any binary search implementation, it should be sorted. Or sorting should be handled by the binary search algorithm. Usually, that should not be the purpose of the algorithm. Algorithm should only perform the search. But yeah, the data should be sorted in some manner. And how you handle the sorting, it's up to you. So, what does binary search do? Well, basically, binary search breaks the data into half with each attempt to find the value within that data. So, let's say, for example, you have a list. You can also call it array. In Python, we call it list. You have a list of 10 integers, and you want to find an integer. Now, we are assuming that these 10 integers are in sorted order, and you want to find an integer within that list. So you will start by hitting the middle of the list, and in each iteration, you will go on throwing away or discarding the remaining of the list, one half of the list, and go on proceeding further until you actually find the value that you are looking for. So, how binary search helps you is that because you are literally halving the size of the data with each iteration, you're going to perform this in logarithmic time, right? So the order of um, the runtime that binary search normally has is log n. That's how you actually indicate it, O of log n, right? You can usually order it. You can usually read it as in the order of log n. Let's have a look at. Okay, this is something which we already spoke about, but don't worry, I'll share this presentation. So let's say this is the array that we want to search, and our input data is this, and our target that we want to find is 11. So we go to this input data, we go and look at the value in middle, and the value in middle. Now you don't have to look at the value in middle. You can look anywhere in the input data, and basically you discard the remaining part of the data, which is not valuable to you anymore, given the value that you have found in a given location. But okay, let's not confuse too much. Let's start with looking at value in the middle. So value in the middle now. Okay, first of all, notice that this is a sorted array or a sorted list. So value in the middle in this case happens to be 120, right? Now I know that the data that I'm looking for, 11, is less than 120. And I know that these are sorted in like ascending order with smallest on the left to the biggest on the right or towards the end of the list. Um, so what I can do is I can discard everything starting from the middle to the right because I know that the value that I want is in the left of 120, right? So I discarded that. Now what I'm left with is these four values, 11, 17, 89 and 90, as you can see over here. Now once again let's hit the middle, but hey, this time it's four integers, so there is no definite middle. So what we are going to do is we are going to just simply take an integer division, and we'll say basically start, which is 0th index, plus end, which is 0, 1, 2, 3, third. So 0 plus 3 is 3, and we'll divide it by 2, right? So when you divide it by 2, it will give 1.5. But if you try to cast that into integer, if you try to convert that into an integer, because remember 1.5 is a float value. So if you try to convert that into an integer, it will give you 1. Basically, it will just discard all the non-integer part of the value, which is 0.5, and it will just return you the integer. So it will return me 1 in this case. Now the value on the 1 happens to be 17, right? So again, I can discard everything from 17 till the end because I know the value that I want, 11, is less than 17, so it has to be on the left of the 17. right? Now in this case, in the third iteration, I'm left with only one value. So now our input data is just 11 and our target is 11. We will literally perform the exact same algorithm. We will reduce the end by middle minus 1, basically just to the left of the original middle, and we will look in the middle. Now the value in middle happens to be 11. How did we calculate the middle? We did start plus end divide by 2. Now in this case, start is 0. By 0 I mean 0th index, because remember this is a list with only one value in it and programmers like to count from 0. So start is 0, and because it is a list with only one value in it, even the end is 0. So 0 plus 0, when you divide that by 2, you get 0. And the value at the 0th index is the value that you're looking for, right? So how you end it? In the return, you simply return the index of the value of the middle that you have at this time, because that's the value which corresponds to the original list. Okay, yeah. I think it is. So first I'm going to start a Jupyter Notebook. If you don't know Jupyter Notebook, or if you have not heard of IPython or Jupyter earlier, you should check it out. Google it quickly. Um, Jupyter is just a web-based environment which allows you to execute your Python code on a web browser instead of doing it through a terminal. So you can actually run the piece of code that we are going to write now on any Python interpreter, as long as you're using Python 3, because that's what I'm using for this purpose. Um, but yeah, you don't have to rely on Jupyter Notebook per se. So let me go to my terminal and start a Jupyter Notebook. Alright, so I am here in Jupyter Notebook. Let me start a new Python 3 shell or a Python 3 notebook. Okay, so here I am, right? Now we will start with an input array. So let's actually take an input list. I'll quickly type it up. Right, so I have this input list. Now notice that this input list is not already sorted, but binary search expects you to have the data already sorted. Now for this purpose, we are going to use a Python function which will simply go ahead and sort it for us. So I'm going to say sorted input list equals sorted function, and then I'll put the input list in it. Now when I say print sorted input list, I have the same list, but this time it is sorted, right? Okay, let's start with implementing our binary search. Let's start implementing this as a binary, as a function, right? So this function will take some parameters. Let's say it will take what to find, basically something that we want to find in the list. It will take the list in which we want to find, so we can call it input data. It will take a start point. We'll talk more about it, why a start point, and it will take an end point. So by default for start, I'm going to say start at index 0, which is the first element in the list. Let me actually zoom in just to be sure if it's visible clearly. Yeah, so which is the first element, and I want it to end at the last element, right? So the last element for me is this. So by default, I'm going to set the end as length of the input data, right? So this is the default value. Okay, now first of all, let's handle the base condition. What if there is only one item in the list, right? So if there is only one item in the list, then just check that the length is only 1. If length of input data equals 1, and if what to find equals sorted a list, sorry, I changed the name, input data 0, then return 0. Why are we returning 0? Because that is the index of the value that we wanted to find in the input data, right? Else, now because the length of the input data is only 1, and what we want to find is not on the first as the first item in the list, it means it doesn't exist in the list, right? Because the length is only 1. So we can simply return value does not exist in the given input data, right? So this is the base condition. We handle the base condition. Now let's come to implementing the actual function, right? Now remember when we were looking at here, throughout we needed the value in the middle. That's how we wanted to start, right? So let's start by calculating the middle. And remember we need the integer value, right? So let's say calculate the middle of the input data. So middle equals int of start. Start by default is 0. End, which is this, and then you divide this by 2, right? So middle is basically you take a mean of it, take an average of it, right? So now we notice we took the integer and we didn't allow it to be float, because otherwise this would have been a float value. We can actually quickly check over here. So what I'll do is, so let's say if start is 0 and input data is let's say end is 15 because the size of the list is 15, then start plus end, let me put this in bracket, divide by 2, and let me print all of this, is 7.5, but as I wanted was the integer value. So which is 7. Okay, so we should have the bracket around the whole thing. Right, so now we have the middle, right? Just to ensure this is giving an integer value, we did the integer cast in it. Okay, so let's start looking at the value in the middle. So if the target, which is the value to search, is the value at the middle, return middle and stop, right? Because we found our value, it's done. This is the best case scenario. We looked it and we immediately got the value. So let's say if input data middle equals what to find, then you return middle, because middle is the index in the input data where the value exists that we want to find. Okay, I'm putting in comments so that it's very easy to follow in case you look at it in future. And I'll share this Jupyter Notebook in a GitHub repository, and I'll put the link to that repository in the video description as well. Right, so this was the if condition. What if the value is not in middle? Actually, let me put that as a comment. What if the target is in left half of input data, right? By left half, what I mean is the value that we want to find, is less than the input data, the value at the middle, right? So now we are doing this. So value that we want to find is less than the value in the middle, which is, in this case it's 120, but over here whatever, right? Now because it is less, we want to reduce the end to be 90. In this case 90, basically one less than the middle, right? So if that is the case, we will leave start as 0, what we already had, and we will reduce the end as 1 less than middle, right? Which is just to the left of the original middle, right? So this is the case if the value is in the left half of the input data, or the value that we wanted to find is less than what we found in the middle of the data, right? Now the next side. So what if the value that we want to find, we are calling that what to find, is actually greater than the input data, right? So now we are saying, what if the value that we wanted to find is actually on this side? What if we wanted to find 954, which is on the right side of 120 in these integers, right? In that case, we want to leave the end. Okay, let's actually start with the middle. In that case, we want to increase the start by 1. So basically, we want to move just to the right of the middle, right? So we'll say start equals middle plus 1, and end we want to again leave as the original end that we had over here, right? As over here, right? So basically we are moving just to the right of the original middle, and in this case we are leaving it as default value, which was length of input data, so that we search the entire remaining list, or we are calling it input data. Okay, great. So we did both the conditions. Finally, what if it's not there in the left or in the right, right? Basically, what if, let's say we want to find the value 100, it doesn't exist anywhere, right? So finally, we just want to say again, return the same thing. I'll just copy and I'll say value does not exist in the given input data, right? And finally, so we did all the conditional checks. We checked if the value is in the middle, if it is less than the value in the middle, or greater than the value in the middle. Now each time we are setting the start or end accordingly as we want to set based on what value we found in the middle. And in each iteration, we want to keep on calling the binary search function. Now this concept may sound a little bent, so stay with me, right? First, let me write down the code. So we are calling again the same binary search function. We are basically recursively calling binary search function. This is called recursion, right? And I'm saying input data start equals start, which I set over here in this setting, and end equals end, again what I set over here in these conditions, right? Okay, so let's look at with a little bit of depth on binary search, right? Let's actually do this over here. Okay, I forgot a semicolon. Let me quickly change this. I'll call this input data. Right, we are good. Okay, this was just, I messed up the variable names, right? Now recursion is basically you are recursively calling the function itself from the function's own definition, right? So we are recursively calling binary search, but with each iteration we are reducing the size of the list by changing the start and the end values. Let's take a proper example. Let's say our input list is 1, 2, 3, 4, 5, right? Let's say this is our input list, and value we want to find is, let's say, 4, right? Now what we do is we start with the middle. In this case the middle is 3, so we say now the value that we want to find is 4. Let's actually change it to 5 so that there is slightly more iteration. Okay, so the middle value is 3, so middle value is 3. This is not the value that we want to find, right? So what we do is we change the start to the one right of the middle. Remember, we are in this condition right now, right? What we want to find is greater than the value in the middle. We want to find 5, but the value in the middle is 3. So we are in this condition. So what we do is we change the start to middle plus 1, right? So our new start is 4, right? Our new start is 4. Now our new input list is 4 and 5, right? Because we changed the start to new and we kept the end as it is, right? So the input list remains as it is, but our search focuses on only these two elements in the list, right? So it would be wrong to say input list is this. Input list remains as it is, but our search focuses on the values 4 and 5, right? So now we again try to calculate the middle of the new start and end. So now the start for us is 0, 1, 2, 3. So the start is 3 and the end is 0, 1, 2, 3, 4, right? So the end is the last element or the length of the list. You can call it 5 if you want. 1, 2, 3, 4, 5. Because we're using end as the length of the list as over here, right? So our new middle would be start plus end divide by 2, which is 3 plus 5 divide by 2. So this comes to 8 divided by 2, which is 4, right? So the new middle value is 4. Now what's at the 4? 0, 1, 2, 3, 4. On the value on the 4 is 5, right? So middle index is 4 and value in middle equals 5, right? Uh, so now we will again look at the value in middle, and this time the value in middle happens to be this. And so when we will return the value 4 because we are returning the index middle. We are returning the index middle as you saw over here. Return middle, right? So I hope this makes a little bit of sense. If it does not, I would say watch this video again. So remember, we are recursively calling the function itself that we are trying to address. And in each iteration, we are reducing the size of data by changing the values of start and end. If it makes sense, we could actually change this to middle index. Right, so the reason I'm doing this so that start and end do not confuse with start index, and so we are looking at the index values and we are trying to see the values at that particular index in the given list. I know this sounds a little bent. That's how it actually sounded to me as well when I first learned about this some time ago, a few years ago. But yeah, eventually you get a hang of it. All right, now let's put this function to use. I'm going to comment all of this code and I'll leave it over here in the notebook, and I'll share this notebook with you all through a GitHub repository. Let's try to put the above code to use. Let's say our input list is this, so I'll just copy this all, right? We have our sorted input list in the variable called input data, and I'm going to pass this to binary search. So I'm going to say print binary search. What to find? Let's say we want to find the value 8. Okay, before we do that, I'm going to print input data just so that we see the index values for each of the value in the input data. And now I'm going to say print binary search in the input data, and I'll leave start and end values to default what they were. Oops, okay. Right, I forgot to change middle to middle index. Alright, so this is at the value 2. So remember, this is the input data. So this is the input data, and this is the value that we want to find, which is 8, and that is at the index 2. Now let's actually put some comments so that we can see how many times did the search actually ran, did the iteration actually ran, right? So at the end of each check over here, I'm going to call over here. Actually, let me call it this start, running binary search, right? And over here I'm going to call index, right? So see, to search in this big list, it ran only 4 times, right? So new start index originally was 0 and the end index was 6, which was the middle of the list. Then because the value that we were trying to find was less than the middle, which is 8, and the middle is, let's say, around 15, 17, whatever it is, the end index changed to the left, right? So the new end index became 2, and this time the value that we wanted to find was actually more where we ended, and it came to start index increased to 2 and the end index remained 2, and we came to the value 2. Right? So this is how you actually go ahead and implement a binary search in Python. I am hoping that it makes sense. Again, if it does not, please go ahead and watch this video again. Binary search is slightly a a concept, but if you keep at it, it tends to make sense. At least that's how it worked for me. Thanks for watching. Once again, please do let me know in comments how you found this video. if you were able to implement this on your own, and if it was informative or not. And if you haven't subscribed, please, please, please do subscribe. It really encourages me to create more such videos. Thanks again and have a good day.